Hello and welcome to this Unreal Engine tutorial. I'm the Festmaster, and today we're going to be making a scanning system similar to the game Scanner Sombre, where all the geometry of the world is invisible, and you have to hold down click to make these dots that form along the geometry, and they're the only things visible that you can use to have any sort of sense of what space they are. They change colors as they get further away, and they are visible through solid walls. Well, solid walls that are invisible. But ones on the opposite side of the same wall are not. Alright, so let's get started. To begin with, we need to make our environment just a little more apt for this project. So I'm going to start by just deleting all these physics cubes. And then with those deleted, I'm going to use these, just scale them up a bit more, move them up, to create a sort of environment. Delete this as well. We don't need the reflection capture, we don't need the sun lamp, yes. We don't need the atmospheric fog, and we don't need that. We can even go into unlit mode. Well, just stay unlit. We can make a sort of, it's a bit dark, but we can like make something here with different rooms and paths that we can end up scanning to see. And then once that is done, I'll just grab this floor, make it a roof as well. So that's a quick thing we need to do for our level, and then if we can select all of our geometry, we want to scroll down and under rendering, make the actor hidden in game. That makes these all invisible during play. Now there's a couple things we want to do next. Let's create a new material, and we will call this dot. And now this is going to be the material for our glowing dot. So what we want to do is search for pixel depth. And this will get how far away that pixel is from the camera. We want to subtract from it, and I'm going to be using scalar parameters for all of the input values so that they are easy to change in a material instance. We'll call this offset and set it to 200. Plug that into B, and then we need a divide. We can hold D and click to get a divide, and then another scalar parameter S and click called depth max. And this I'm going to set to 2048. And then this will be plugged into the B of the divide. Now we actually need to get another subtract here and subtract that max, as well as another divide. And then what we want to search for is power, and get two of these, plug one on each of the divides, and then we want to get a saturate and plug one of these onto each of the divides as well. And then we want to get two lerps, which we can hold L and click for, and plug these saturates into the alphas of each. And then we want to hold I and click to get an if, hold 1 and click to get a 1 constant, which we just need to set to 1. And then this saturate goes into A, the 1 goes into B, this bottom lerp goes into if A is greater than B, and if A is equal to B, and then if A is less than B goes into the top lerp. Now if we hold V and click, not V, sorry, 3 and click, we can make some 3 vectors. And I'm not doing these parameterized because they're just going to be primary colors. The first one we want to be red. The second one we want to be green. And the third one we want to be blue. You could parameterize these, but since all the dots are going to be working the same way, we don't really need to change the color of the dots. And so the red will go into the first lerp's A, the green will go into the first lerp's B, and the second lerp's A, and the blue will go into the second lerp's B. And what this is going to do, if we start previewing this node, and we zoom away from our sphere, we'll notice we lerp from red to green, and then from green to blue. And we have these, and the power gives us like a curved change. It's different than a straight up linear change. It's more of a curve, sort of like how these wires go, rather than a straight line. It's just more pleasing to the eye. Alright, now we'll need to hold M and click to get 2 multiplies. And plug this through both. Hold S to get a scalar parameter, and we'll call this emissive strength. And this needs to be plugged into B and set to be around 20-ish. And then what we want to find is a radial gradient exponential. This is a material function, and we don't need to change any of its properties. Just plug it into B on the first multiply, and then we want to plug it into opacity, and then this into emissive. And then with this selected, we need to change some of its settings. First of all, we need to change it from opaque to translucent, and then from default lit to unlit. And if we put it on a cube, is this working? It should be working. Stop previewing. Ah, that's what it was. I was previewing the if. And so there we have a dot. Easier to see it if we just put it on a plane. And this is going to be the dot that we use for our for the dots of the scanning thing. Now if we save this, we are done with that material. So now in our blueprints, we can make a new blueprint class, base this on actor, and we can call this dot BP. And now in here we want to add a component and a plane. And then we want to take this plane and rotate it by 180 degrees so it's completely upside down. And then set the scale to be about 0.15. Oops, and I forgot to lock it, because we want it to be a small square, like so. And then this material set to dot. No. Dot. There we go. And so there we see we have this dot on the plane. And then in the event graph, we want to do a delay off of begin play, promote this to a variable, and we can call this dot lifetime. or not call it dot lifetime. Dot lifetime, and then compile this and set it to be, I'll just set it to be 1,000. This will be how many seconds the dot will live before it gets destroyed. And then just destroy actor. And that's all we need for the dot blueprint. And then we can open our first person character, and we'll definitely need to change some of these things. So first of all, we can delete all of this spawn projectile code. We don't need any of it. But we do need this input action fire. And we also need the event tick. Now if we hold G to create a gate, we want to plug pressed into open, released into close, and then hold B to get a delay, and the tick through the delay into enter. And then set this time to be 0.01. So what this will do is basically, out of here, it'll fire every 0.01 seconds while our fire key is down. Now we need to make a new function real quick. We can call this line trace, and it will need two inputs. The first a float, and the second a rotator. We can call the first input distance, and the second offset. And distance, we can change the default value to be something like, I don't know, 5,000. That should be good. Now what we want to do is a line trace by channel. And then we want to get the camera, get world location, and get world rotation. And this we want to combine rotators, plug our offset into that. The get world location can just go straight into start. We will get the forward vector, multiply this by a float, and that'll be distance, and then add a vector to it, and we'll use the get world location for that vector as well, and plug that into end. And then we can pull out our return node here, plug the return value and the out hit into it, and compile that. Now here, back in our event graph, we want to call that line trace function. Like so. And then now we need to basically set up an offset so that you're not scanning directly in the center of the screen. It sort of like does an area around. And so we want to make a rotator, and then get a random float in range, and we want to make 3 of these, and I'm just using control copy, control paste to make more. And then if we select one of these, promote to variable, we can call this scan range. And then we want to take this and multiply it by another float, and that float be -1. And so the multiply will be plugged into all the mins, and the default value plugged into all the maxes. Now if we compile this, we can set scan range to be about 15. And then hold B, click to make a branch to check we have hit something, and then break our hit results. And we will want to spawn actor from class, set this class to be .bp, and then split this struct pin, the spawn location, to be the location, and then we search for find look at rotation, and we, off of the start, we want to make vector and just plug the impact normal into the target. And so what this does is it'll start from 0 to the world location that is the impact normal, which will be exactly 1 unit away from 0, and find that direction. Now what we could have done is taken the location and plugged that into start, and then taken the location and added the impact normal and plugged that into target to find it, but we don't need to do that extra math because it'll have the exact same result, because it doesn't matter whether the origin of that line is at 0 or at the location of the actual hit. Then we can just plug the return value straight into the transform. So if we compile and save, that should be all. I almost forgot one thing. Under volumes, we will need to find a post-process volume. Pop this into our scene. Never mind. We actually have one in our scene. If we go into the world outliner, should have one. Post-process volume, here it is. And so what we were looking for is exposure. Minimum and maximum brightness are set to 1, so that is exactly what we wanted. And we want to find the bloom intensity and set this to 0. And then search for unbound and infinite extent unbound. That is already set up. So if we go and play, we'll notice now if we hold down our click, we'll start like painting these dots. And apparently these walls don't have collision. Default block all. Let's try that again. I see. It is not rotating the planes. That's odd. Let's see, it is movable, so it should be rotating. And we have this set up correctly. So what I'm going to do is I'm going to take this and I'm going to make uncheck hidden in game and just drop a little point light in here so I can see what's going on. And so if you can see, the planes are not being rotated. They're all that's interesting. If we rotate that, there we go. So now they're aligning to correctly, and then if we just take this and pull it forward a tad, they will not be clipping on anything, and we'll be able to scan. So I will just set this back to hidden in game, delete this light, and here we go. We can play, And here we are. We're able to scan the world, and if you notice, we can see dots through objects, but we cannot see dots on a wall like from the other side. So on the other side of this wall, we can't see the dots on it, even though they're there, but we can see dots that would be facing us. So, and this is the principle behind the entire game, Scanner Sombre. And as you notice, the dots change colors, they get further away. And so here it is replicated in Unreal. Now there are a couple other things within the original game that I did not replicate, namely there's multiple ways to scan. There are lines coming off of the scanner that go to every dot when it's created. But these things can be set up very easily. Getting these dots, the dot mechanic itself working, is the primary thing. So anyway, there we go. Mechanics very similar to Scanner Sombre. And thank you for watching.